Welcome to Electronics Specify Insights, the podcast for electronics engineers. I'm your host, Paige Hookway. In today's episode, I speak with Carmen Redondo, Director of Global Marketing for Antennas at KYOCERA AVX, to explore how non-terrestrial networks are transforming global connectivity and the critical role antennas play in making satellite-to-device communication a reality. The conversation covers the engineering challenges of designing antennas for NTN versus traditional terrestrial networks, with a deep dive into KYOCERA AVX's investment in laser direct structuring technology, a technique that enables complex 3D antenna geometries particularly suited to space-constrained IoT devices. Carmen also discusses the company's award-winning S-band LDS capped antenna, highlighting its dual circular polarization and what sets it apart from competing solutions. I hope you enjoy this episode. Let's get started. Hello everyone and welcome back to Electronics Specify Insights. Today I'm pleased to be joined by Carmen Redondo, who is the Director of Global Marketing for Antennas at KYOCERA AVX. So thank you very much for joining me once again, Carmen. I know you've been on an episode previously. It's amazing to have you back. So for those who haven't listened to us before, would you mind just quickly introducing yourself and telling us a bit about who you are and what you do?
Thank you, Paige, for having me. So as you said, I'm Carmen Redondo, and I'm Director of Global Marketing for Antennas. And my education is in engineering, in telecommunication engineering, and antenna. I'm specialized in antenna design. So I've been many years working and doing the antennas myself. And then after different roles, I end up in marketing, which nowadays is very exciting role because, it's every year there's new wireless technologies emerging.
Fantastic. And would you mind just telling us a bit about KYOCERA AVX as well?
Yes, so we are a leading global manufacturer of advanced electronic components, and we have different type of products like capacitors, connectors, filters, sensors. And then among all of them, we have the antennas. We have several sales and manufacturing centers around the world, and for antennas, we have what we call design centers, which are in the US, Asia, and also in Europe. And those design centers, they have labs, and we help customers integrating antennas because it's not an easy product to integrate, and we can help in the integration and also validation.
Excellent, thank you. Well, let's deep dive into your specialist subject then, which is antennas. And to set the scene, how is NTN, your non-terrestrial network, reshaping connectivity? And what role do antennas play in making satellite-to-device communication truly viable?
So this is a very exciting topic, because just to give you an idea, 70% of the planet is not covered with terrestrial coverage. So if you manage to have this communication via satellite, you can imagine the amount of different applications you can have either in the ocean, on the remote areas where there's not connectivity. So in the past, they used to have proprietary protocols and, of course, satellite communications, but more expensive. The modules were more expensive, antennas bigger, the services. And a few years ago, with the release of the 3GPP release 17, they defined the standard for non-terrestrial networks. And this accelerated the development of modules. They're using the cellular modules also for NTN. And this gives advantages to bring applications like in IoT, where you can expand much more thanks to that. So if you're using the same modules and you also want to use the cheaper antennas, smaller, so you can imagine the important role of the antenna because we are the one closing the link, and the satellite, of course, signals are very weak and coming from far away. So antennas, normally in wireless communication, they play a very important role, but in satellite communication, it's even more important.
So given that then, what are some of the biggest engineering challenges when designing antennas for NTN compared to, say, traditional terrestrial networks?
So the biggest challenge, besides, of course, that the signal is very weak coming from very far away, from the Earth, is also that the satellites are providing circular polarization. For the ones who are not familiar in the technical terms, let's say like the signal is rotating, moving towards the Earth. And normally, if you want to use a hybrid antenna, if you want to use the same antenna that you use for terrestrial, that means that your antenna will be linear. So you will lose part of this signal. So this, of course, people might say, oh, but this is what's happening with GPS. In the cell phones, you have linear polarized antennas, but the GPS receivers have much better sensitivity. And also, they can catch these signals, but also they are not really much transmitting. In NTN, you're having communication. You also want to transmit data in both ways. So this gives even more weight of importance for antennas.
Now, I know that KYOCERA has invested heavily in LDS technology. So what makes that such a game changer for antenna design, especially in what we've been talking about, space-constrained IoT devices?
So yeah, as you said, we have been many, many years using LDS, but mostly for custom designs. But the advantage is also not only on the size or to use the whole volume of antennas, it also gives you flexibility on the design. This is why we have created antennas in LDS for NTN, and that allowed us to have circular polarization, which with other technologies, manufacturing technologies, might have been more either not as cost efficient or more difficult to implement in production and have other kind of difficulties.
Perhaps you could dive a little bit deeper for us. How does LDS enable more complex 3D antenna geometries, and what practical benefits does that bring to engineers integrating these solutions?
So LDS, for the ones which are not familiar, means laser direct structuring. And we are using some plastic resins which have some particles that when you pass the laser on them will get activated. And during the plating process, you will, plate the antenna pattern. So that imagine instead of having 2D structures like metal or flexible PCB and transform it into 3D, which is not fully 3D because you're coming from a 2D. Here you can use a real 3D structure in plastic and then have the pattern that you want. So some years ago, and which actually was the podcast we have a couple of years ago with our tulip antenna. So there we were doing an antenna which had constant phase from the antenna. So we could do this weird shape like a tulip, and that allowed to have more accuracy in ultra-wide systems. Now we're using LDS in this case to create 4 fits, which are having some phase difference between them. And that allows that has circular polarization, which again, with other technologies might have been more complex. And this is very ideal also for IoT because it's a very light part, which also, for example, in terms of drones is very useful. And also it has SNT properties. So it's a design that you can directly put on your PCB, same as other type of components of your PCB.
Well, thank you for mentioning Tulip, because that's still one of the best named products I think I've ever come across. And well, as you know, it won our Electronics Excellence Award a couple of years ago. And I know you guys have won one this year as well with your S-band antenna. So perhaps you can walk us through the key features of that antenna, particularly its dual circular polarization, and why that matters for satellite applications.
Yes, so this is one of our NTN antennas, the S-band. And so some of the characteristics I already mentioned, right? Like you have very lightweight, so it's just a plastic, right? Compared to some other parts, which could be metal or for example, patch antennas, which are very used in satellite communications. They are ceramic and they are very heavy. This is very light. You have it as is SMT, it's compact. Even people say, oh, it's very height, but in reality it's hollow inside, so you can place components below the antenna. It's very reliable, so it's over metal, so you can have it in applications where it's a lot of metal around. And then the key thing, which is about the polarization and gain. So this antenna compared to patch antennas, it has very constant gain towards low elevation angles. So from the zenith to the azimuth. And that gives benefits for satellites, like for example, LEO satellites, which are moving around. So when you go low elevation, you can still have a reliable connection, but also geo satellites. So we have customers which are in South America, and maybe the geo satellite is in North America. So they won't see the satellite on top, but they will see in low elevations, and this helps. Now, in terms of polarization, this antenna is very special because, as we mentioned in the words, it can have dual polarization. So depending how you configure your PCB, you can have the right-hand circular polarization on the left hand. So depending the satellite provider you're using, you can use one or the other with the same antenna.
What is it exactly, do you think, that sets it apart from other solutions currently on the market?
So as far as I know, I think we are the only manufacturer that provides this type of solution that you can change the polarization with the same antenna, and also to be able to cover, in a cost efficient way. And I think we have also other types of antennas in the same form factor. So I think we are the only one right now doing this.
Yeah, and that leads me on nicely to my next question, which is, you offer a wide range and variance of antennas. So how do engineers decide which band and antenna type best fits their application?
So this is a bit the marketing role. So that's why it's so important to understand. And we have many partners where we understand what are the needs. Of course, when you are doing a custom design, you can have any type of band, any type, you are more flexible in that. But when you want to create standard products, especially in IoT, where there are customers with different type of volumes, you want to be ahead and give them the solution already prepared that they can buy in distribution. So the band will depend on the satellite provider that you are using. For example, if you're using Satellite, they are having the S-band with the right-hand circular polarization. So this is the type of antenna we recommend. But if you're using Viasat, in that case, they're using the L-band. So in that case, you might want to use the L-band version instead.
I'm interested to hear, what are some of the most exciting use cases that you're seeing from these LDS cap antennas? Is it asset tracking, industrial IoT, automotive, or something else?
Something very important to have in mind is that for having circular polarization, you need to face the sky. So, for example, the asset tracking, I will say, in most cases, not the most suitable antenna for the cap antennas, because normally the trackers you cannot combine, except for some animals where you can have them in the fixed position. There are applications like sensors and many different industrial applications where you're having a fixed position, or at least you can control it, so it's facing the sky. And also in automotive. So in automotive, we have the cap antenna has participated in some trials with major OEMs. And actually is in the external version. So we have the cap antennas integrated in a housing with IP, so we also can have the external antenna version of this.
Fantastic. And looking ahead then, how do you see antenna design evolving as NTN and satellite IoT scale? What's going to be the next big innovation beyond today's LDS cap antennas?
So we still have one more version coming in our roadmap that many people is waiting for it, and it will be in a few months this year, which is going to be dual band. So it's going to be the L band plus the S band and dual polarization, left hand and right half on the same antenna. So we are going to have an active version. That means that the same antenna will be able to connect directly to any L or S bands or different polarization. That means they give you the flexibility to different constellations. And this is very important. For example, if you want to have a device that connects to GEO and LEO, or for example, with the Skylo. Skylo is using different bands depending on the region and also different polarizations. So that gives you the advantage of not having to worry where your device is going to be. You can just have one solution that would cover all the different solutions. Now, going ahead, we also are looking in the NTN 5GNR. So this is the next version of the NTN, will come in a few years. And we're talking to partners. So we have some things there I cannot mention so much. But yeah, that will be the next step.
Oh, teasing us now, aren't you? Fantastic. Many exciting innovations ahead. Is there anything else that you'd like to discuss before we wrap up?
Just I would like to remind everyone the importance not only of the antenna, of selecting the right antenna, but also in the implementation. I think it's very important to have a trustful antenna supplier or manufacturer where it can help you in the way to make sure that your wireless devices are connecting fine. And we are very happy to help on our side on recommendations. You can always contact us. But this is very important. It's not a product that you just buy and implement, but I think it's very important to have this validation and make sure it's fine, because it's a key difference if the wireless device will be successful or will have some challenges later on in certifications or field performance.
Yep, definitely. Well said. Thank you very much. Well, it's been a pleasure catching up, Carmen. Thank you very much for joining me again on Electronic Specifier Insights, and enjoy the rest of your day.
Thank you. You too.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.